Okay, let's examine some discrete random variables in the context of this problem right here. And this is some problem involving insurance. And this insurance company will pay out a certain amount of money depending on the outcome. And in this case, they will pay $10,000 in the event of a death, $5,000 for a disability, and no money, of course, if you neither die nor have a disability. These numbers, by the way, are pretty small. I'd get a different insurance company if it was me. Okay, now a couple of things to note here. X represents our variable. And X in this case is a discrete random variable because they will pay $10,000 if it's a death, or they will pay $5,000 for a disability, or they will pay zero money. X here can only be $10,000, $5,000, or $0. There are no other monies expressed in this table. These are the only possibilities that can happen in this particular example. All right, so X represents the payout. It's done in terms of whole numbers, and only 3 possibilities are available. Now, when dealing with probability distributions, we need to know the values that X can take on, but we also need to know their associated probabilities. Now, insurance companies draw on information from many different sources, very many different insurance companies over long periods of time. And I guess according to their information, in general, you can expect 1 in 1,000 people who may die for whatever particular reason. That 1 in 1,000 really represents our probability, and if we work that out, we get the decimal 0.001. Okay, their information shows them that they can expect 2 in every 1,000 people may result in a disability. That gives us our probability 0.002. And on the other hand, out of 1,000 people, you expect 997 of them will have neither a death nor a disability, and gets us our probability of 0.997. Now, there are 2 basic properties of probability distributions. One which says that probabilities for any value of X have to be numbers that fall between 0 and 1. And we can see that here with these values right here. The probability is either 0 or at most it's 1, or it's somewhere in between, which is what these numbers represent. One of the second properties of probability distributions tells us that if we add up the probabilities over all values of X, those probabilities have to sum to 1. So right here, here's our probability of a death, 1 in 1,000, probability of a disability, and probability of neither. When I add these up, I get 1,000 over 1,000, and of course that equals 1. So that property is met for this particular example. Now, whenever we have values of X and we have their associated probabilities, we generally want to know what's the expected value. And in this case, the expected value represents the money, the payout, that an insurance company will have to pay out over, in this case, I guess it's over 1,000 people. So if they have 1,000 policyholders, what is the average payout that may be due to death or disability? So your notes say you have to take each value of X, so here it is, 10,000, 5,000, and 0, and multiply those values of X by their associated probabilities. So here's the amount of money for a death, there's the probability of a death. The payout for disability times its probability, and for neither and its probability. And when you work that out on your calculator, it turns out to be $20. So on average, we could say on average, the insurance company expects to pay out $20 for 1,000 people. We can also say that that $20 represents the expected value. Expected values are not always the value that they will end up with it turns out the expected value is generally the value that has the highest probability of occurring. In this case, we're looking at $20. Let's just say this insurance company had, oh, I don't know, maybe they had all the people who perished on the Ocean Ranger in 1984. If they had insured all those people, their payout in that year certainly would have been much higher than $20. So the 20 represents the expected. It does not necessarily represent the value that we will get in actual fact.